This is the review video for the topic number 7 test homework review. So first they give us a graph of the function f of x equals x cubed minus 6x squared plus 3x plus 10. And we want to know where it's increasing, decreasing, has a local max, and has a local min. So since this is the graph of the original function, we're just looking where this is happening on this current graph. So part A wants to know where it's increasing. So as you move to the right, where are your y coordinates going up? So there's two sections. There's this section in here, and there's this section in here. You kind of have to estimate your x coordinates a little bit. Each of these go up by 0.4. So it's for increasing, it's going from negative infinity to about 0.2. This is where it turns. And then again from about 3.2 to positive infinity. For decreasing, it's this part in the middle where as you move to the right, your y coordinates are going down. So from 0.2 to 3.2. Local maxes are the top bumps where you go from increasing to decreasing. So it's going to occur at x equals 0.2. And for local mins, it's the bottom bumps where you go from decreasing to increasing, and that would be at x equals 3.2. Number 2, they give us the function f of x equals 7x cubed minus 12x plus 3. And part A, they want us to find the derivative. So bring the power down in front. 7 times 3 is 21. Reduce the power by 1. It becomes an x squared. Bring the power down in front. Negative 12 times 1 is negative 12. And then your x just drops away. So you get your f prime of x is equal to 21x squared minus 12. Part B, they want us to calculate f prime of 4. So that just means we're going to plug in a 4 every time we see an x. And you get 324. C, they want to know where f of x is or whether or not it's increasing or decreasing at x equals 4. So since f prime of 4 is 324, that's positive, which means your function is increasing. Where your derivative is positive, your function is increasing. Where your derivative is negative, your function is decreasing. Part D, they want us to write the equation of the tangent line. So we need to find the y coordinate first, which is if you plug in 4 into the original function, so you get a y coordinate of 403. Our slope we already found in part B, f prime of 4, which is 324. So if you plug that into point slope form, you get y minus 403 is equal to your slope, 324 times x minus 4. It didn't say what type of form to write your equation in, so you could have just left it in this form. I simplified it down into slope-intercept form, so I distributed the 324 and then added 403 to both sides, and you get y equals 324x minus 893. Number 3, they give us an equation of a curve to be y equals 3 plus 6x squared minus 4x cubes, and it passes through points P and Q. Part A, they want us to find dy dx, which is finding the derivative. So 3 just drops away, derivative of a constant is 0. Bring your power down in front, reduce your power by 1, you get 12x. Same thing on this one, you end up with negative 12x squared. So your derivative dy dx is equal to 12x minus 12x squared. Part B, they want you to verify that P and Q are stationary points. That means that your derivative at those x coordinates are equal to 0. So if you plug in x equals 0, which is the x coordinate for point P, into the derivative, you get a slope of 0. So that means yes, P is a stationary point. And then if you plug in 1, which is the x coordinate for Q, into the derivative, you again get a slope of 0. So that means that Q is also a stationary point. Part C wants us to find whether each stationary point is a local minimum or a local maximum. So I put our x coordinates for the derivative onto our number line here. And if you plug in a point that is less than 0, so I plugged in negative 1, you get a negative number, which means your function is decreasing at that point. If you plug in something between 0 and 1, so I plugged in 0.5, you end up with 3, which is positive, which means your function is increasing. And if you plug in something bigger than 1, you get a negative number again, which means the function is decreasing. So decreasing to increasing, that is a local minimum. So point 0, or x equals 0, which is point P, is a local minimum. Increasing to decreasing is a local maximum. So point Q is a local maximum. Number 4, they give us the function y equals 2x cubed minus 9x squared minus 24x plus 3. And part A wants us to find dy dx, the derivative. So you end up with 6x squared minus 18x minus 24. Part B wants us to find two values for where the derivative is equal to 0. You could either use your graphing calculator or this factors. If you factor out a 6 and then you factor this, you get 6 times x minus 4 times x plus 1 is equal to 0. So your x coordinates are negative 1 and positive 4. Part C wants us to find the coordinates of the stationary points. So we already found the the x coordinates. So we need to find the y coordinates, which means you're going to plug it back into the original equation. So you get one stationary point to be negative 116 and one to be 4, negative 109. Part D wants us to determine whether those stationary points are local mins or local maxes. So same thing as number 3, I'm going to put this on our number line, put our x coordinates that make the derivative 0 onto our number line, and test points in each of these sections. So if you plug in something less than negative 1, you end up with a derivative to be 36, which means it's positive, which means the original function is increasing. If you plug in something between negative 1 and 4, like 0, into the derivative, you get the slope is negative, which means your original function is decreasing. And if you plug in something bigger than 4 into the derivative, like 5, you end up with a positive number, which means your slope is positive, so your original function is increasing. So here you're going from increasing to decreasing, so that means that x equals negative 1, or the point negative 116 is a local maximum. Here you're going from decreasing to increasing, which means at x equals 4, or 4, negative 109, you have a local minimum. Number 5, they give us that Kitty and Betty are standing on the same side of the radio mast, and we want to figure out how far they are. So here's our little diagram here. We have our angles of inclination, how much they're looking up, and we know that the radio mast is 198 degrees, and we want to figure out how far apart they are. So I'm going to find these two distances using tangent functions to be able to find the distance in between. So looking at the big triangle, which is where Kitty is standing, you have the tangent of 32 degrees is 198 over, I call this distance y. So cross multiply, you get y to be 198 over the tangent of 32 degrees, which is 316.8662368 meters. Then same thing for the little one, I'm going to look at Betty's triangle here. The tangent of 43 degrees is 198 over x. Cross multiply, you get x to be 198 divided by tangent of 43 degrees, which is 212.3290046 meters. And the distance between them would be the difference between that. So subtract the two of them, you end up that Kitty and Betty are 105 meters apart. Number 6, they give us a function f of x equals ax squared plus 4 over x minus 3, which I rewrote as ax squared plus 4x to the negative 1 minus 3. And part A wants us to find f prime of x, the derivative of that function. So if you take the derivative, bring the power down in front, 2 times a is 2a, reduce the power by 1, you get x. Bring the power down in front, negative 1 times 4 is negative 1, negative 1 minus 1 is a negative 2, and then the negative 3 goes away. So your derivative is 2ax minus 4 over x squared, or 4x to the negative 2. Part B wants us to find the value of a, given that f of x has a local maximum at x equals negative 1. So what they're trying to tell you here is that f prime of negative 1 is equal to 0. So if I plug in negative 1 for x into the derivative, that whole thing is equal to 0. So I did that here. You get 2a times negative 1 minus 4 over negative 1 quantity squared. So 2 times negative 1, you get negative 2a. 4 divided by negative 1 squared. Negative 1 squared is a positive 1, so you get minus 4, and we know that's equal to 0. So then if we solve this for a, you get a is equal to negative 2. Part C then wants us to find the equation of the tangent line at x equals 2. So I plugged in negative 2 for a into both the original function and the derivative. And I want to find, first I found the y coordinate at x equals negative 2 because I'm finding the original function, or using the original function. So I plugged in negative 2 for a, and I plugged in positive 2 for x, and got the y coordinate at x equals negative 2, x equals positive 2 to be negative 9. And then I needed to find the slope of our tangent line. So I did the same thing, but with the derivative. I plugged in negative 2 for a and positive 2 for x. So you get negative 4 times 2 minus 4 over 2 squared, which is, again, negative 9. So this is the y coordinate, and this is the slope. So I used point slope form. I got y minus our y coordinate is equal to our slope times x minus 2. Again, it doesn't tell you what form to leave it in, so you could have left your answer in this form, but I simplified it down into slope-intercept form, so I distributed the negative 9 and subtracted 9 from both sides and got y equals negative 9x plus 9. Number 7 gives us that a closed rectangular box has a height of y centimeters, a width of x, and a length that's twice its width, so 2x, and that the surface area of the box is 300 squared centimeters. So I found, or part A wants us to find that 4x squared plus 6xy is equal to 300. So I found the surface area of the box, which is the area of all the rectangles added up. So there's two rectangles that have a dimension of 2x times x, so the bottom and the top. There are two rectangles that have dimensions of x times y, so the two sides. And there are two rectangles that have dimensions of 2x by y, the front and the back. So if you add all of that up and set it up equal to the known surface area of 300, you get your 4x squared plus 6xy equals 300. So then part B wants us to write an expression for y in terms of x. So basically they want us to solve this thing for y. So I subtracted 4x squared from both sides and then divided both sides by 6x. You get y is equal to 50 divided by x minus 2/3 x. Part C wants us to show that the volume of the box is 100x minus 4/3 x cubed. So the volume is the three dimensions multiplied by each other, x times 2x times y. But we want the volume in terms of just x. So I'm going to take this that we just solved for y and plug it in for y. So you get 2x squared times y, which is 50 over x minus 2/3 x. And then distribute your 2x squared in, you get 100x minus 4/3 x cubed. Part D wants us to find this should be dv dx, not dv dt. So part D wants us to find dv dx, which is the derivative of the volume with respect to the x coordinate. And so bring your power down in front, you get 100 minus 3 times 4/3 is just 4x squared. Part E wants us to maximize the volume of the box. So part I wants us to find the x and y coordinates that will maximize the box. So maximums occur when your derivative equals 0. So I set our derivative equal to 0 and solve for x. Normally you have to plus and minus, but because we're talking about dimensions of a box can't be -5 centimeters wide, so we just take the positive for dimensions. And then I solve for y by plugging x into part B, the 50 over x minus 2/3 x equals y, and you get that y is equal to 6.67. And then double I wants us to find the volume at the maximum. So I took the volume equation that we found here in part C and plugged in x equals 5 for our x coordinate. And we get that the maximum volume is 333 centimeters cubed. Number 8 gives us that a function has a negative derivative between x equals 1 and x equals 4, and that the point P 4, has a gradient of 0. So we want to find, for part A, the tangent line to the graph at at the point P. So I have y minus the y coordinate is equal to, they tell us the slope at that point is 0 times x minus 4. So 0 times anything is 0, so you get that you have a horizontal tangent line at y equals 2 at point P. Part B wants us to state whether f of 4 is greater than, equal to, or less than f of 2. So we know that f of 4 is less than f of 2 because your slope, f prime of x, is negative, which means your function is decreasing. So between 1 and 4, your function is going down. So that means that the y coordinate at x equals 4 is going to be lower or smaller than the y coordinate at x equals 2. Part C wants us to, or gives us that the function is increasing from 4 to 7, and we want to know what can we say about P. Well, if our function goes from decreasing to increasing at x equals 4, then x equals 4, or point P, is a local minimum. So number 9 is a review from topic number 2. They give us a box and whisker chart and ask us some questions about it. So part A wants us to find the range. Well, they tell us, or if you look here, you can see that the maximum is at 7 and the minimum is at 2. So the range is 7 minus 2, or 5. Part B wants us to find the upper quartile and the lower quartile, or Q1 and Q3. So the end of, or the beginning of the first box is your Q1. So our Q1 is at 3. And the end of the box, or the end of the second box, is your Q3. So that's about 5.5. And then part C wants us to find the IQR, which is the difference between the two of them, or the length of the box, which is about 2.5. Part D wants us to find the median, which is the middle of the box right here, so at 4. And part E wants us to find percentages. So what you have to remember is that every chunk is 25% of your data. The length here just tells you that that section is more spread, but every whisker and every box is 25% of your data. So for part I, more than 3, well, that takes up 2 boxes and a whisker, so that's 75% of your data. And between 2 and 3 is just 1 whisker, so that would be 25% of your data. So this has been the review video for the topic number 7 test.